Hello and welcome to Teacherless. Today we're going to be talking about all five of the chemical reactions that can occur. And at first I believe there was six. Supposedly there is five. So I'm going over five. And if there is a sixth, I apologize. But let's get into it. So, first one that we have is synthesis. This is where an element in an element make a compound, or an element in a polyatomic ion make a compound. Decomposition is the exact opposite of synthesis. I feel like that's quite self-explainable. Just a compound into an element in an element, or an element in a polyatomic ion. Now, single replacement is where we have an element with a compound. And essentially in this specific synthesis example, the positive element is being swapped with the positive element of this compound, which turns into AC and B. So that's what's going on there. For combustion, we have an energy source. Now, an energy source could be, for example, wood, or an example like that. Just anything along those lines. And there will always be oxygen. So whether or not the example says oxygen, it will normally say burn, which is referring to oxygen because you need oxygen to burn something. And the products will always be some amount of CO2 and H2O. No matter what, they will always be CO2 and H2O, and nothing else besides that. And then double replacement is similar to single replacement, except you have two compounds swapping into two other compounds. And so let's start with synthesis. But actually, before we do start with synthesis, I do have to say, none of the equations I'm going to explain actually say the states of them. For example, let's say sodium nitrate. Sodium nitrate is soluble in water, which makes it aqueous. So normally, you should say that it is, in fact, aqueous. I did not. You should already be able to do that yourself, which is why I didn't mention it. That's fake reasoning, though. I'm actually just lazy. So I did not write them. I would suggest that you do, and I would not just suggest it. On all tests, you have to. So, let's start. Magnesium and oxygen react. So, we know magnesium is an element on the periodic table. Oxygen is also an element on the periodic table. And oxygen is a element that's often going to be in O2 form, as in it's going to be like a gas. So when you look at it, magnesium, Mg, charge of +2, and oxygen has a charge of -2 in its O2 form. So magnesium plus oxygen, I feel like this is quite explainable what will happen. It's going to make magnesium oxide. Magnesium oxide. I believe that's what it's called. And there must be two of them, because the magnesium has a charge of 2, which means there should be 2 oxygen, and the oxygen has a charge of -2, which means there should be 2 magnesium. So it's pretty simple to just put the 2 over here for like explanation's purpose. So let's go to a single replacement. Oh no, this is decomposition, sorry. So sodium chlorate heats up to produce. Now it's important to mention that heats up is not the same as burning. If I shake you a bit, you're going to get heated up. If I set you on fire, you're going to burn. So this is just decomposition. Heating up a compound is an example of like a way to decompose a compound. There's some other ways that you can do it too. But most of the time we'll say heat. So, sodium is an element, charge of +1. Chlorate is ClO3, that's a polyatomic ion, you should know that by now. That's a charge of -1. So we write that together, sodium chlorate. Yep, sodium chlorate. And of course this is going to just break apart into sodium chlorate and oxygen. And it's important to remember that we have to keep these balanced. So that's why we have to write the 2's over here and the 3's. Because, of course, if it wasn't balanced, then that would be quite problematic. And actually, now thinking about it, this is not quite self-explanatory. You might assume that the sodium and the chlorate will break apart by itself, making sodium plus chlorate instead of sodium chloride and oxygen. But the issue with this is that chlorate by itself is not very stable, and it would most likely become a polyatomic ion, which is sodium chloride, and oxygen, which is the element. So let's move on to the next one. So sodium and aluminum iodide react. So this is single replacement. Sodium is Na, and we have aluminum here. That's Al, charge of +3. Iodide, charge of -1. It's important that I mentioned that iodide is I negative, because iodide is very similar to iodine, which is just I. And so for chloride also, which is Cl, I also mentioned the, you'll see later that I mentioned Cl negative, which is why it's just in parentheses right here, just to distinct it from the elements that are very similar. So anyway, the actual reaction, looks like I skipped a slide, sorry about that. But sodium is by itself here, and aluminum, there must be 2 or 3 iodides, because iodide has a charge of -1, and aluminum has a charge of +3, which means that in order to balance it, there must be 3 iodides and 1 aluminum. And then that just swaps out. The aluminum and the sodium are both positive, so they just swap. And of course, the iodide stays the same for now at least, and we'll balance it on the next slide, where because of the fact that there's 3 iodides on the reactant side, there must be 3 here. And if there's 3 iodides, then we're going to have to put the 3 over here, which means that we also have to have 3 sodium. And that balances it out. So next, combustion. Here is where I mentioned burns. This would literally just mean that it's adding an oxygen. So octane burns into. So we already know what octane is. We have it right there. And we know that's going to be adding with oxygen. And we know that there's supposed to be some quantity of CO2 and H2O. So if we balance it out, we get 2 octanes, 25 oxygen, 16 carbon dioxide, and 18 H2O. And I am skipping the balancing section because the balancing is quite easy. And if we have this written out, there will eventually be some numbers, and these are the numbers here. I'm not going to do balancing because that takes like just a decent amount of time, and I'm trying to make these videos quite short, so I'm not going to mention balancing. So let's move on to the next. This is double replacement, and the last final one. You'll notice that these are quite easy, and this is actually supposed to be the first video that I made, but like the public demand, I guess I'll say, suggested that I make this video now, so that's why I'm making it now. But anyway, double replacement, which I also went over in the net ionic equation video. Potassium sulfate reacts with barium chloride to form. So we know potassium is positive, barium is positive, sulfate is negative, chloride is negative. So then potassium is a charge of +1, barium is a charge of +2, sulfate SO4 charge of -2, and chloride, as I mentioned earlier with iodide, let me go back to that, I negative. Over here it is Cl negative, just to distinct it from the element, which is just Cl. And that's a charge of -1. So we write that out. You have to remember that sulfate has a charge of -2, so we need 2 potassiums to balance that out. And barium has a charge of 2, and chloride has a charge of -1, so we need 2 chlorides to balance that out. So now, as I mentioned in the net ionic equations video, the 2 positives are going to switch, and I mentioned that earlier too. So it's just barium sulfate and potassium chloride. Now this is not balanced, or maybe it is balanced. So yeah, it is actually balanced. I thought I had a secondary slide. But yeah, this is just fine in the way that it is. And so before I move on to some practice problems that I listed for you guys, it is important to keep in mind the solubility rules and just solubility in general. So as I said earlier, over here, we got to write all equations which each compound state. So if we go back to the double reaction, all of these should have the states mentioned. I did not for the sake of simplicity, but it is important to mention aqueous and not aqueous like solids or liquids, because that's going to especially be important in net ionic equations, which is why I had to mention it in that video, and I didn't mention it in this one. And here's a couple of practice problems, so I'll give you a second to look at that. Diethyl pyrocarbonate, just so you know, I believe that's just wood. I don't know why I found that as diethyl pyrocarbonate. That should just be wood. But if you search that up, that's kind of what it just showed up as. And so these are all the answers for that. Give you a second to look at that. So yeah, C6H10O5, I believe that's just wood. I don't know what diethyl pyrocarbonate is, but it's very nice. And that's everything. Shout out to Heather and Emerson. They didn't help making the previous video, but they wanted a shout out, so give them one. And please subscribe. I'm going to keep making these. If you've noticed, this video is in dark instead of white. I assume that a white text on a black background would be a little bit better for the eyes. And have a good night, or good afternoon, or whatever you're experiencing. I don't really know.